Welcome to the lecture on 8085 microprocessor architecture. Before we proceed with the microprocessor architecture, let us discuss the fundamentals of microprocessor. An ideal microprocessor consists of n number of inputs and m number of outputs. The input and output both are in the binary form. The input which we apply could be from the input devices like switches, sensors, A to D converters, keyboards, tape recorders, and this input is processed as per the dictates of the program, and an output is generated which is also in the binary form. And the output devices may be actuators, lamps, alarms, indicators, D to A converters, CRT displays, etc. When we discuss about 8085 and its buses, let us discuss about the features of 8085 microprocessor. It's an 8-bit general purpose microprocessor that can address 64 kilobytes of memory. It's a 40-pin IC which requires plus 5 volts of power supply and can run at a maximum frequency of 3 MHz. That's the processing speed. The pins on the chip can be grouped into 6 groups: address bus, data bus, control and status signals, power supply and frequency, externally initiated signal, and serial input-output ports. Let us talk about address and data bus. The microprocessor needs large number of pins for the input and output purpose, but the microprocessor chip cannot afford to have large number of input-output pins because of limitation of the pin numbers on the IC package. Therefore, value of M and N are limited, usually equal to N. So, what we do over here is number of pins are reduced, and this is possible by using bidirectional pins which could act as a data path width, or which could be used as a data bus. Bus is basically a group of lines. So address bus, it's a group of address lines, 8 signal lines, A8 to A15, which are unidirectional, dedicatedly used for addressing purpose. Whereas the other 8 address bits are multiplexed, that is time shared, with the 8 data bits. So we must say that on the same address line, data as well as address could be sent, and AD0 to AD7 are bidirectional bus. So here A0 to A7 acts as an address line, D0 to D7 at the same time it would act as a data line. So during the execution of the instruction, these lines carry address initially. It acts as an address bus initially, and later on the same address lines are also used to carry the 8-bit data. In order to separate the address from the data, we can use the latch to save the values before the function of the bit changes. Now, this is the control and status signal. There are 4 main control and status signal, which is ALE, read-write, input-output memory, S1, S0. ALE basically is an address latch enable. This signal is a pulse that becomes 1 when AD0 and AD7 lines have an address on them. So whenever it is activated, that is active high, the data which is being carried on this line is address. Later on, when it becomes 0, the signal can be used, same bus can be used to pass the data. So this is address latch enable control signal. Then read operation, write operation, then input output memory related operations. This signal specifies whether the operation is memory related or input output operation. When IOM is 0, it is memory related operations, and IO related operations when it is 1. So status signals to specify the kind of operations, we use S1 and S0, usually unused in small systems. Now frequency control signals. Now there are 3 important pins in the frequency control group. X0, X1 are the inputs from the crystal or the clock generating circuit. The frequency is internally divided by 2. So to run the microprocessor at 3 megahertz, a clock running at 6 megahertz, that is divided by 2, comes to be 3, should be connected between x0 and x1. Then there's a clock out and out clock pin to drive the clock of the rest of the system. Microprocessor communication and bus timings. Let us understand that in the next lecture.